we all know, the most common and traditional type of grasping machine is rigid grasping robots. However, it cannot fit the trend of development of grasping machine. So the scholars started to research on soft grasping robots. It mainly uses soft materials such as silicone to build grasping machines. However, as I went to do another engineering project in Jiangsu University, I found out that the process of designing and developing soft grasping robots need a great cost of time and materials. And the soft materials is actually less durable than the traditional rigid materials such as metals. So I was thinking about, can I use rigid materials to build flexible grasping machines? Because I am really interested in origami, so it reminds me of a video about how origami is applied in engineering. So I think that maybe I can build these flexible grasping machines based on the origami structure. So I did a few research and I found out first, to build a flexible grasping machine, most of the scholars still use the method of soft grasping robots. The second is that those who applied origami into grasping machines only simplify the structure without considering the problem of flexibility or adaptability. Or I found out that they have their ideas originated from an origami artwork. However, they actually have little relation with origami. So I think that maybe this research topic is really worth more research. Then I started to develop my own project. I mainly have two routines. The first one is the more traditional 3-finger origami grasping machine. This is the first version of this 3-finger origami grasping machine. It uses servos to pull the strings, and about the fingers, it was based on the origami structure that's shown in this picture. About the origami structure, I've also done a lot of research on it. I tried this origami structure, but it cannot be bent or it cannot be compressed. I have also tried this one. This one really works well in this paper model. However, when I started to build it based on PP materials, I found out that it is too hard to even bend at all. This kind of origami structure is actually the best, mainly because it is kind of solid instead of hollow. It is also very simple in folding it. So I think that this one is the best for mass production. I did 2 experiments for the 3-finger origami grasping machine. I found out that the maximum weight it can grab is only 250 grams, which really needs more improvement. And I also found out that it cannot grab thin object or rectangular object. However, comparing to the other design, it can really provide more protection. So I did version 2. There are mainly 2 improvements. The first one is that I use small electric actuator to pull the strings instead of the servos. The second improvement is the covers added to the end of the fingers. This cover actually first increased the contacting area between the fingers and the object being grabbed. A silicone layer on it will help increase the friction. So with a few experiments, it turns out that the maximum weight it can grab increased to 700 grams, which I believe is a very great improvement. Horizontal direction friction it can provide also prevent those rectangular objects to slip through the fingers. So then I will introduce you about this pneumatic origami grasping machine. It was mainly made of 2 parts. The first one is the air chamber made of balloon, and the second one is the endoskeleton inside the air chamber that is both based on the origami structure shown in this picture. And here is a paper model of it. I've also done 2 experiments for this pneumatic origami grasping machine. The conclusion is that the maximum weight it can grasp is more than 1.5 kilograms, and I think this is quite satisfying. And I also found out that it can successfully grab most of the object, except the sharp object, because it has a really great force of grabbing. It is easy to break fragment object. So based on these conclusions, I thought of 2 improvements I can make. The first first one is to change the material of the ear chamber to increase the durability, and the second one is adding the pressure sensor between the ear chamber and the endoskeleton. Now this project only requires some simple coding, but I think there are still a few further improvements that need to be made. The first one is to add pressure sensors, and the second one is to use AI and deep learning to calculate the best grasping force, and the third one is to combine these two simple flexible grasping machines with vision sensors and image recognition system.